Okay, so I think I have time for one more question. So this is question number 8. Below are shown structures of 4 possible bromination products of toluene. Indicate the product or products formed in significant amounts when bromine reacts with toluene under each of the following catalytic conditions. So the first condition is Br2 in the presence of a peroxide catalyst, and the second was Br2 in the presence of FeBr3. So let's do A first. So basically the toluene molecule looks like this. There is a methyl group there. And the first instance is Br2 in the presence of a peroxide catalyst. And usually with this reaction, you need UV light. That's not answered in the question, but I'm just going to add it there. So when you have Br2 and peroxide and UV light, I'm not going to draw out the mechanism because it's really complicated, but basically you end up with a structure that looks like this. So this is our carbon that is here. And this reaction, the mechanism occurs through a free radical process. I'm going to rewrite that here. So this occurs through a free radical process. Basically, you need UV light for these types of reactions because you really need to add more energy in order to have reactions that occur through the radical process. And what's cool about this reaction is that the bromine is attached to the carbon that is least substituted. So we call this Markovnikov. Just label this as benzyl bromide. So since this is an anti-Markovnikov addition, it's not that favored if the UV light and the peroxide weren't there. So this is the final product that we get for part A. For part B, we're going to do the same thing. Write down toluene. And this time, it's Br2 in the presence of FeBr3. So for this question, is just a standard bromination. So you can have bromine either on this carbon So this is the ortho position. Or that was a really, or you can have the bromine down here. So this is the para position. So this process is the opposite of the other one. This is a Markovnikov.